are some Birkeland currents. You might want to get familiar with these because these have a lot to do with our planet. Actually, everything to do with our planet. You can see they twist around. Those are Birkeland currents in space. On to the left there, NASA calls them black hole nebulas or something. I don't know. Anything but what they are. They're Birkeland currents. They're plasma. But that's one right there. They're real. There's some more right there. And yep, there's those are them too right there. Universe seems to be made up of them, filaments. NASA's baffled by them, but pretty easy to explain. There's some more Birkeland currents right there on those dress. We also have that in the electric universe. But if you're into black holes and man-thongs like Seahawks and Oswego, you can always go to the NASA channel because they have lots of those there. Let me get this ball rolling because I got a lot to deal with here and I'm not sure exactly how I'm going to explain it. I'm just going to let it work its way out. But what you'll notice is that if you look at this image right here, it's kind of like a triangle. So what I've done is I've taken all the triangles on our planet and laid them out basically in the same manner. Some of these might be reversed because, to be honest, nobody really knows how this planet was created. We have science that tells us, but to be honest, they don't know. They're guessing upon what data that they have or what they're allowed to expose, because there's definitely somebody holding back information from us. I can guarantee you that. Anyways, let me just show you first how this works. I'll take this first triangle area and just throw it in there so we can get it out of the way. And we can look at it under scrutiny like this. So I line this triangle area up right here, and I'm looking for confirmation. And you can easily see that, look, right here, when I pull this in, you can see it is related. I might have to move it around, but it's under scrutiny, it's always going to add up. Look, this fits right into the, right there, like a glove. You can see that that matches right there, and then you can see that there's alignments everywhere else. See what was here, right here, is now here. And it keeps going. Like, the more you scrutinize it, the more you'll see that it lines up. You can see this whitish area lining up with this, the overspill. As a matter of fact, there's two. You see what looks like a fork right here or whatever. You can see that lines up right there. As this lines up with the Himalayas, a collision. That's what we've been told, it's a collision. And that's what everybody believes, it's a collision. But it can't be a collision. There's no way that can be from a collision. It doesn't even look like a collision. It's so funny because the truth is so right in our face. The closer you look, the more this looks like electrical. It just automatically, I would assume that's the result of electricity. It just looks like it. But you can tell there's a problem with mainstream science when it goes so far out of its way to explain things but not use electromagnetism as part of the explanation. They'll actually create forces that never been seen before and use that rather than electromagnetism. And to me, it seems obvious. The reason is because electromagnetism must be censored, and they're not letting anybody know that, of course. which makes mainstream science a pseudoscience. Electromagnetism is not a pseudoscience, but mainstream is, because they see waves in space and they call it a gravity wave. Well, according to them, gravity needs matter, so there must be a wave of matter following it or something, or else they're better off just calling it a dark energy wave. And I'm still waiting for Seahawks to tell me what the difference between those two would be. You're better off just calling it a magic wave. I think that might convince people. Anyways, I gotta get back to this. But look, you can see that it matches up in other areas, but you keep moving it along and it keeps matching up under the tightest scrutiny right here. And then right here you got this image that I claim is an image of probably a Z-pinch, because you can see this wrapping around and you can see it narrowing, and what I think happens next is it pulls away, and then all this matter comes from somewhere. Somehow it's related. But look at the image right here. Right there. Like that. Okay, this is starting to get boring, so I'd like to go straight to the elephant in the room with this overlay, because there's a problem here with this alignment. You can see that you got like a little notch right there. You got the same notch right there. You can see how that fits in there, and then it fits right here around Japan. You can actually see areas that line up when you put them on top of each other of Japan. There's no doubt that these two are related. The problem is that this is the southwest Indian Ridge in the southern hemisphere of our planet, and it looks like a vortex. But we don't call it a vortex in mainstream science. We call this a ridge, and we even think it's spreading slowly. But then over here you have a subduction zone in the northern hemisphere. Not only does this line up here, but you take that same ridge and you move it inwards, and you'll see that it lines up with other features too. Really good. Even right there. Even all the way to here, I believe. So this is a problem, because this is a subduction zone. Subduction zones is where plates go to die, and this should not be lining up with a subduction zone in any way, shape, or form. The fact that they line up, and I guarantee that they line up under the tightest scrutiny, proves that they're related. I can guarantee you these are related, but they can't be related in plate tectonics. So what do? Do we just pretend they don't line up and go ahead and keep believing in plate tectonics, or do we do what we're supposed to do, which is throw out the theory and start over if the theory is no longer supported by the observable evidence, which plate tectonics is not? They just don't. And I like the truth. I'm not a mainstream science guy. I don't like to just believe whatever they throw at me. So I want to get to the other overlays because they're amazing actually. Look at that right there. To that, to even to here. See how that fits in all these? And the other elephant in the room would be Antarctica fitting in this too, on the opposite side of the planet. What's interesting, okay, here, oh man, I could go for days just talking about this. You can see what looks like rotation because you got it like a probably probably a hexagon that you can't see. But it's, I'll say it's round. You got what looks like the end of a vortex coming to a point, and look how it just fits right in. Right like that. See how it just naturally fits without effort, hitting these islands right here. I can tell you that this circle right here is responsible for so many surface features blamed on meteor impacts that it's not even funny. But you can see how it lines up with the islands. Let me back out so you can see the whole picture. See how, watch it as it hits these islands. See how it keeps fitting? Here's another one that comes to a point. I'll line up the point here, and then I'll start moving it around. Right out the bat, you can see that we have alignments here. See right there, this guy right here, see how it, here's that, there's a crease right here, and that crease helps me make alignments and also get the correct rotation in. I can see that this just has to rotate clockwise just a hair. Okay, so okay, it's getting complicated. Let me bring it right back up here again. Okay, I hate when this thing, I have to move it in and out. See the alignments? Okay, so let me get this right. That right there. See, look. That vortex fitting right into there. But here's the thing though. You see this is cleared out here. I'm wondering if it's related to this. So let me spin it around and see what happens. Like that. Now let's take a closer look. Yeah, see it right here? Yeah, see how it comes to right like that, this, and that. Like that. Look at the, I trip out on the markings on the ocean floor because when you pay attention to what they're showing you, it's amazing. It really does show you so much that people have missed. See this right here and this. And note the beveling on Madagascar. I think it's upside down. I think this is a piece of a continent that actually is spun around. It's been broken off somewhere. See, it sucks because I need to get straight on shots now of this area, and it will line up too once I get the right angle. And it will show you more of the story. That's what's so cool about this. Oh, here you go, look. Here's Madagascar and Papua New Guinea. Okay, look, I bring it in, the tip. As I fit the beveled area in here, you can see that these features are probably lining up right here with the mountains. That's that scrutiny thing I'm talking about. Looks like it needs to rotate. Oh yeah, look at that. Yeah, it's the same width here. As if it was ejected from here. Just checking. Okay, so so that's that. My gosh, this could take forever. But look, okay, I've confirmed these areas here. See how that matches up? Hold on. Okay. Right into here, of course, the triangle part. Looks like it needs to rotate even. Or maybe not. Actually, it's fitting pretty good right here. It might actually just sink in there like that. Yeah, it does, because look. Oops. Yeah, like that. And then notice this area. To make it more transparent so you can see a lot of this stuff covers it up. It's funny how the contrast on some of these images are so intense that it almost makes it impossible to see certain alignments. And I've found this to be the case a lot of times. It's pretty interesting, right? Look. You can see the this probably has to rotate, I bet, but it's good for now though. I mean, I think I've okay, so that's that. Well, that's that for now. There's more I didn't get to, of course, but you could see that this the fact that any of these line up pretty much, in my opinion, discredits plate tectonics and has nothing to do with Pangea, because these are different layers of the same process. That's why they match up, and that's the way it is. But I have more amazing stuff that I have to get to still, so there'll be another video hopefully soon. Thanks for watching.